So hello, in this video we're going to learn how to do hypothesis testing, and more so to do linear regression, both multivariate and of course bivariate models. So I'll start off by just explaining what I'm going to do. So as I said, we are going to handle linear and multiple regression models, and more so we'll do it alongside hypothesis testing. And more so we'll do it alongside hypothesis testing, and we are planning to do this in specifically using R programming. So basically you need three areas here. You need to understand how to do first the code stuff in R. And then two, you need to understand how to do linear regression, linear models in R programming. You also, in this same video, you learn how to do multiple regression models in R. And then from that, after devising the models, you'll also learn how to do hypothesis testing. So we're going to start off by going straight to R and test. So assuming from the data that we had on nulls, we had a variable called profit. Then we had a variable that is this was the y variable. Then we have a variable called let me just change my pen. So we have so that's y variable. Then the x variables, we have the first one being sales. Sales affect profit. Then two, we have unit price. Then three, we have the order quantities. So the quantity sold of a product, and of course the quantities we sell of our products as a company, the prices that we put for those products, and the amount of and the sales we make in a certain period dictate our profits, because it's from the unit price that we know the profit, we know the losses. It's from the order quantity that we get to know the sales, and from all these three combined, they affect the profits. So we go straight into R and see. So we start off in R. So let me just let me clear what I had done. So in my previous video, I had in my other video I did how to load data into R. Let me just clear this so that we can start afresh. I think that's okay. So okay. So now we had reached here in regards to loading data, and of course after loading data into the environment, of course this is my source data. I said it's called it's nulls. If you want to get this data, I'll be sharing a link. You can also comment on the section on the comment sections if you need the data. Then of course seeing what we have and then cleaning it until here. So let's run this code first. So let's see. So we have our data loaded. Let's see what's that. So we have our variables. So we have order ID, order date, order quantity. We have our sales here, of course the shipping mode, then profit. So unit price, customer name, customer segment. All these are not important for now. We'll focus on these four variables. We have our unit price, we have our profit, we have our sales, and we have our order quantity. So we want to know, how is profit affected by sales? How is profit affected by the prices, that is on the unit prices? How are the profits as well affected by the quantity ordered? So how do we do that? We go back to our code and say, so we say let's do the linear models. And before I proceed with the linear models, the reason why I introduced hypothesis testing is we are trying to create a hypothesis that, from the general knowledge we know, is that sales affect profits positively. But is that the case? Perhaps we're selling on credit. From the general knowledge we're having is that our assumption is the quantities, the quantity sold of a product affects positively, the amount of profits we make as a company. But that might not be the case according to this company called Nulls. Then also we are assuming that the prices of our products affect the total profit that we make as a company. But is that the case? So those are the hypotheses that we make before we start doing anything, and those answers will be provided by the models that we run. And of course we see what are the relationships between the variables, the x variables, in this case the 3 variables, and of course the y variable, that is the profit. So we'll see that. So the first thing we need to do is we need to define the model. So we can actually start off by doing individual models. We call them regression 1, regression 2, regression 3. So let's do regression 1. How do you define that? Let's just do it. That should be profit as the y variable, against should be profit against let's say sales. So first of all we need to put the marks, because these are variables and they are quoted, these are variable names. Then of course we're saying data is what? Data we are using the so-called data we said here, data. Yeah. So then this is the first model. The second model, we call it regression 2. Regression model 2, which is also a linear model. Profit, you can actually copy this and then change the variable. That is profit, but in this time round we can run against unit price. I'm hoping that is the name of the variable. Unit price, yes. Then the other model that we want to run, we call it regression 3. We run profit against, what would we run? Against order, quantity. Yeah. So these are the 3 models. Let me see. Okay, supposed to be there. So okay. Then profit. Yeah. So I think that this should be the case. There's too much space there. We don't need this. Yeah. Let me see. Yeah. So there we have our 3 variables that we are planning to do regression models on. So the 3 models are here. So these, if I may rename them, allow me call them linear regression models. So they are just, or rather, apart from linear, we call them bivariate linear models. So thereafter, so let's try and see how these behave. Actually, when the data, you just need, you don't need to name, you don't need to write anything like data here. This is not necessary. As long as you know the name of your data set, this is just for reference. So if we run the three models, you see here, the three models are here. So how do we know what the models contain? So let's see. So view. So let's view what. So let me just close this and. So let's view what the models contain. Yeah. So the first one is you summarize them. So you summarize. You run a summary of what? Of reg 1. Perhaps can copy and paste. Okay. So here it's regression model 2, and this is regression model 3. So let's run one model at a time to see what each models contain. We run that. So this is model 1. We're running profit against sales. Our data is data, definitely. So this is what we have. The coefficients is what we're looking for. So from when sales coexist as a single variable, then the relationship between sales and profit is that it's positive, and of course you can tell from the value of a multiple of R, it's positive. Yeah. But now okay, so let's screenshot these. Let's screenshot these models and put them. Yeah, and let me go explain these models. So if you come here, so let's try and have a look at this model. So this is the first model. Yeah, this is the model between. This is the model between. So this is model 1. Model 1. So model between profit and sales. Yeah, we've seen the relationship when sales is alone is what? Is positive. Is positive. And R, that is a correlation coefficient, is 0.4004. It's here. This is the relationship. I mean the correlation coefficient, and of course R squared. So that means so how you interpret these numbers. So for R squared, you'll say that you multiply this. It's 0.3998. This can be the same as 39. Sorry. This can be the same as 39.98%. This implies that 39.98% of the variation in profits is explained by changes in sales. So sales on its own does not exist as a single variable. Does not explain all the variation in the sales. I mean in the profit, but explains only 39.98% of the variation. So now this is model 1. Is it significant? Yes, it's significant because the p-value is less than. So the p-value is less than 0.05. But this can change. It can be 0.01. Can be 0.10, depending on what is but this is the most commonly used p-value. So if you're given assuming we had set let me just scroll up. Assuming we had set a hypothesis that so assuming we had set an hypothesis that on the null, that is H not. We said there is no relationship between profit and sales. Then perhaps on the alternative hypothesis, we say there is a positive linear relationship between profit and sales. Yeah, so assuming that was what you are assuming that was what you had set before, so definitely in this case, now that we have our R value, so now that we have our p value, given that p value which we've seen is less than 0.05, then it follows in hypothesis testing we reject the null. So by us rejecting the null, we're trying to imply that there's no way we can say there's no any linear relationship. There's no way you're saying there's no okay, supposed to be there's no, sorry. So it's supposed to be there's no, because normally null is a negation, so there's no. So by us rejecting, we're trying to say there's no way we are saying there's no relationship between profit and sales. We have seen that, and we've seen the p-value is less than. From here, we've seen here that the p-value here of 2.2 power negative, e power negative 16, we've seen that truly p-value is less than 0.05, therefore we reject, and there seems to be so how you conclude normally on the process of hypothesis testing. So once you've done with rejecting, that is on the this is called decision. That's the third step of hypothesis testing. Then the last step is normally called conclusion. And how do you say in conclusion? So you conclude and say there is sufficient evidence to support the claim that there is a positive linear relationship between profit and sales. Yeah, so this is the conclusion. If you've done all the four processes, of course you need to provide there's a way you also report results in APA format. Say our regression model was run and we had this and this and this, and this is what we got, so that you can do. This is how you do the process of hypothesis testing when given a regression model. First, you start with stating the hypothesis, whether there's a relationship or not, you suspect. Then 2, you run the test, get the values, get the p-values and get the R, of course. Then come and decide. If the p-value is less than 0.05, then you reject the null. If not, then what do you say, by the way? I forgot to mention that if you say, if assuming the p-value here in this case is greater than 0.05, then you fail to reject the null hypothesis. So you don't accept really the alternative hypothesis, but you fail to reject the null. That means you don't have evidence enough to reject, so you can't reject. You say you fail to reject. These are the words you need to use in statistics. If you don't, then you'll be communicating your own language. So after you've said that, and then thereafter you need to conclude why is that the case. There's sufficient evidence from, now one of the evidences, now that we're seeing the sufficient evidence here, one of the evidence is the value of R. We've seen is 0.4004. Already 4.004 is positive. 1, 2, it's there's a linear relationship. There's a communication of a linear relationship. Then perhaps is not that strong. It's about more, because the value of R ranges between -1 to 1. So I mean, depends. So something closer to this is very strong. Something closer to 1 is very strong. But you see, this is almost halfway. This is 0. So there's a way you conclude. If it's 0.04, 0.4 is still a weak relationship, but at least it's positive. So there's a positive weak relationship between profit and sales. So back to our code, back to our R. Let's see what the second model had to say. The second model was between profit and unit price. Let's run that and see. Let's see the summary. Just run that only. Okay, we didn't change here. So let's run this and see. Yeah. So there we go. Let me see if I can clear this. I can clear that and then rerun the model. At least it's on the top. Yeah. So here we go. Let's also do the same thing. And actually, I don't need to do the same thing here. What needs to happen is now the same process I did in the first model. You go check first. It's between profit and unit price. So one of the hypotheses will be, that is the null hypothesis, will be you suspect there is no relationship between profit and unit price. Then on the alternative, you say you suspect there is a positive, or there's a linear relationship between profits in a company, and of course the unit prices of products. Then you go ahead and check the coefficients. Something else I didn't show you, so let me use this one to come up with to illustrate what I want to show. So something else I didn't show you guys is that they will require you to formulate a model. They'll ask you, where is the model? Please define the model. So let me just put it here. So this is it. Just do that. So now, yes. So let me define this and say drafting the model. Yeah. So here we go. We have this is the output. So the linear model will be given by, so any linear model is given by in the form of y equals to b naught plus b1 x, where b naught is a coefficient, is the intercept, y-intercept, then b1 is the slope. It is the same thing that we did in high school, or I think in high school, something about y is equal to ax plus b, or mx plus, there's also ax plus b, and then there's y equals to mx plus c. This is a question of a straight line, same linear, straight, same thing. So you just need to understand the whatever is happening. I'm just trying to draw from what you know. then now to take you to this new concept. So when you come to derive the model, so your y predicted will be profit. So profits will be given by what is the intercept? The intercept is here. The intercept is here. It is what? 146.2801, depending on the number of decimals they tell you to give, plus 0.7724. What? Our x, what is our x? Unit price. So this is the general format of the model. You need to give this. They'll need to see this. Where did you get this question? This, are you copying from somewhere or what? So let's just write in short form. P to stand for profit equals to 146.28. Let's give it to 2 decimal places. Then plus 0.7724. Just 2. Okay, no, let me not add 24. Unit price. So this is the model. This is how you derive a model from the intercept, and then pick the coefficients and then match them with the respective variables. So now that we know how to derive a model, now we know how to do the hypothesis testing. Why don't we now go and run a multivariate? Whatever we are doing is bivariate linear models. You can see it's only 2 variables, the y and the x. But now what if we have more than one variable on the x, and we're trying to run a model? So let me illustrate that. Let me explain this. So let me pick this. So multiple regression model, or multivariate. You can still call it multivariate. Multivariate to mean multiple variables. Multivariate. Okay. Yeah. Multivariate. So we have our y, and then we have our x's. So here our y is profit, then our x's so x1, we have x1, we have x2, and we have x3. So x1 we said is sales, the one that we actually did. X2 is unit price. Then x3 is what? Order quantity. So we want to know if these 3 factors coexist together in a model. All these 3 factors, how do they affect profit? Because sales on its own might be positively affecting profit, but what if combined with other factors, like prices, other factors like order quantity? Yes, you might be selling a lot of you might be having very high prices, but still there are a lot of there are a lot of orders coming in, so that means you're selling more. That means your profit won't go down, in as much as yes, price might be negatively related to profit. But what if other factors come in? The profitability of a company is not determined by just profit, sales, whatever is. There are so many factors that affect profit. It's not just selling. It's not the amount we sell actually, or it's not the prices. There's a way all these factors come together to form one model that if well utilized and if we know the right areas to manipulate, then the company can make profit. We need to understand the relationships when these variables coexist together, and then how do we manipulate that to ensure that the company makes a profit. So we go run that. We've said x1 is sales, x2 is unit price, x3 is order quantity. Our y is what? Is profit. So back to our R. So this time around we're creating a, so let's create a multivariate model, and we intend to do that. We call it rig multiple, and we define it by LM, linear model of what? First we say this what is profit against sales. But now this time around they are not coexisting alone. We are adding what? We are adding unit prices, unit prices. Then we're also adding order quantity. So now of course we need to tell it we are picking from our data that we have. So we've called this regression multiple regression model. If we run that, what do we get? Said error in evaluating unit prices not found. Okay, I think it's the naming. Let's see, unit price. Okay, let's see how it's named. Unit price, or it's price not prices. Let's do that. Let's do away with that. Then rerun the model. Now we have a model, regression multiple. But now let's see what do we have in that model. So we get a summary. We get a summary, some summary of our regression multiple. And if we run this, this is what we get. So let's steal it first in screenshot, so that we go discuss it on the other platform. Yes. Then come here. Now let's see. Let's now understand this. So this is the multiple regression model. We have all the factors coexisting together. This time around we want to know, yes, you guys coexist together, but what is it that you guys do? So here we go. We have our model. It's a multiple regression model. So we have our sales, we have our unit price, and we have our order quantity, and these are the coefficients. Now notice something else. When these variables exist alone, the value of R on its own is very weak. But if you notice in this case, the value has gone up to 0.5621. Initially, remember, with sales alone, the value of R was 0.4004. Here we're talking about 0.5. So the more variables you include in a model, as long as they're significant to that model, then you expect we expect the prediction to be close to reality. And by close to reality, it means that the R will be headed towards 1 or -1, depending on the relationship between the variables, because can be negative, can be positive, depending. The values here, the signs, the signs just show the direction, the nature of relationship, but in reality this is very weak. No. What it means is that this is very strong, this is positive, this is negative. That means this is positively correlated, this is negatively correlated. Now let's develop our model and say, so model, let's call it a model. So the model, so let's give it the general format. So y predicted in this case will be given by b0 plus b1 x1, where in this case we know our x1 is cells, yeah, then plus b2 x2, and we know very well our x2 is unit price, then the final is plus b3 x3, where we know our x3 is order. So let me just label it down here. It's order quantity. So this is the general format, and we know this is profit. Yeah. So this is profit. So this is the general format of the model. This is how the model will look like. But how it will look like exactly, the exact format. So the particular model, this is how we derive the model. So we pick, let me just do it with this. Yeah. So now let's do the model. So assuming so the profit here, just try and change for my position of, so profit will be given by, what is our b1? Our b1 is normally our y-intercept. It's here. So 37.09 099, just let me put it 0.99. Then the next thing is you add, so added 2 so added 2 0.3299, yeah, 99 of what, of cells, then plus what, plus -2, which basically means we're subtracting again. So minus 2, yeah, 2.41 of unit price. It's unit price, then minus 8.771, but what, order quantity. So now we know this. Now this is the final model. But now remember, when cells coexisted, I mean when cells was alone as the x variable and ran against profit, it was positive. It is still positive. Unit price is negative. If you go to model 2, the second model, what was it? The second model, if you confirm that, you see, so it was the unit price was positive, but you see now in this case things have changed. What are we talking about? We're talking about a negative relationship. Why? Because the prices alone cannot fully affect profits. Let me just return that. So you notice the relationship now is, I mean the relationship with between unit price and the profits is what? Is positive when unit price is alone. But when introduced with other variables, the profit, the relationship now is what? Is negative. So this is the nature of how these units combine, and these factors combine, and them combined together do not necessarily mean they will affect the variable the same way they did when they were the only variables in the model. So this is how you do multiple regression. Let me also show you how to know which factor is significant. So here, this is significant because the p-value is less than 0.05. Same to this, significant. But if this value was something greater than 0.05, then that would be insignificant, and we are supposed to remove that model, that variable in the model. But in this case, this is also significant. So in interpreting this, of course, you'll say all the factors, all the variables were significant, and then of course give the t values, the p values, and that's how you report in a PA format. Yeah. So this is basically it. You need to do some practice, understand how these things are done, and of course be quite sure how to do your stuff in R. In my next video, I'll try and explain other ways of doing hypothesis testing using without necessarily using R programming, or without necessarily using also regression models. You can also use ANOVA, can do other stuff. I mean, can do some other models like T, Z, and proportions. So join me in my next video. But meanwhile, don't forget to like, share, and subscribe, and ensure you watch the full video and see what exactly how I'm doing these things. I'll also be posting shorts on these short videos on the same, just to take you through the whole outline on how the videos have been created, just to make things a little bit spicy and interesting. Thank you very much. Let's meet on my next video.